Okay, in this video, we will like to answer the questions such as for second order linear equations, when the solution exists, and the second one is how do we find them. Okay. Not just find one solution, we want to know how to find all the solutions. Okay. Let's look at the first one. Equation 1. Any second order linear equations can be written in this form for given initial conditions yt0 equal to y0, y0 here is a number, and y0 prime there is a number 2. Okay. In this section, there are so many theorems. You need to read all of them carefully. I don't want to make this video too long, so I'm not going to state all the theorem precisely. Okay. I just want to emphasize the important points. Okay, first theorem basically say, if the coefficient p of t, q's of t, g's of t continues on an open interval I containing t0, okay, t0 here is our initial point. Okay. If p, q, g, those three functions continues on interval I containing t0, then problem 1 has a unique solution. Okay. Now let's look at an example of it. Say we have like t squared minus 2t y double prime plus t y prime minus t plus 3 y equal to 0. Okay. And y, when t equal to 1, y equal to 2. And y, when t equal to 1, y prime 1 equal to 1. Okay, for this problem, we want to find the longest interval that for this problem has only one solution. Okay. So as what we just stated, what do we need to find? First, we need to find the P, Q, and the G first. Okay. For this equation, we have to write, okay, what we can say about this equation? This equation is a linear, second order, and homogeneous, okay, with the g's of t equal to 0. Now, to use the conclusion we just stated, we need to write this one in the format of equation 1. So, we divided t squared minus 2t on both sides. Therefore, our piece of t here is t. I'm going to plus sign here, sorry. T over t minus t squared minus 2t. Q's of t here is negative t over t squared minus 2t. And the g's of t equal to 0. Okay. So what we need to do is find out where, for what t, p's of t continues, so is the g's of t, q's of t. Okay, look at p's of t. This is a rational function which will be continuous for all the t in the domain. So what is this function is fine. Okay, this function is fine. It's a good one, except t equal to 2 and t equal to 0, right? When t equal to 2 or t equal to 0, you have 0 as a denominator. Your function is not defined. So, this function is continuous on every point except t equal to 0 and t equal to 2. So, piece of t continues here, here, here. In the other words, they will continue on the interval negative infinity to 0, then 0 to 2, then 2 to positive infinity. Okay, so So is for Q sub t, same reason. G sub t is 0, it's continuous everywhere. So therefore, the longest interval we're looking for here, you have 3 intervals. We're looking for the one containing t0. Our t0 here is 1. So 1 is here. So only this interval. So our answer is 0 to 2. First of all, in this interval, open one, your function is continuous. Second, this interval containing t0. So we solve this problem. Okay, now let's answer the second question. Okay, in the second question, we're going to dealing with this one. Y double prime plus p sub t, y prime plus q sub t, y equal to 0. The differences between equation 1 and equation 2 is this one we say is what? It's homogeneous. So equation 2 is called the second order linear homogeneous equation. Now, the next question we'd like to answer is, how do we find all the solutions for equation 2? In order to do that, we need to understand some properties about equation 2. For the second order linear homogeneous equation, we have a very important property. They say like this: if y1 and y2, they're both solutions of equation 2, then like 3 times y1 is also a solution. Okay, I strongly suggest you check that. And y1 plus y2 is also a solution. In general, c1 y1 plus c2 y2 will be solution 2. Read the book, they verify that. Let me say that again. For the second order linear homogeneous equation, if y1 and y2 are solutions, then linear combination with arbitrary c1 and c2, they are both constant, then this one still be solution. I'm not going to check that here. You can read on the book. Okay, now, our next question. This is the important property. Let me write my equation again. Y double prime this is what we'll call equation 2. Okay, next, let's see how do we find all the solutions for this equation. So first of all, we need to find something called a fundamental set. Of solutions. What do we mean fundamental set of solutions? They are 2 solutions, y1 and y2, such that Wronskian determinant of it Wronskian determinant defined this way: y1 and y2, y1 prime and y2 prime. Okay, you know how to find this determinant, right? It's like this: y1 times y2 prime minus y1 prime times y2. So you multiply those two, subtract those two. Okay, y1, y2 prime minus y1 prime, y2. Okay, if determinant of Wronskian determinant is not 0, then we say y1 and y2. Let me say here. Then we say y1 and y2 form a fundamental set. Let me say it again. What is the fundamental set? Fundamental set of the solution equation 2 is you need to find 2 solutions. If you find the Wronskian determinant of those, Then if not 0, then we say y1, y2 form a fundamental set. Then any solution of equation 2 can be must be in this form. We call this a general solution. Okay, so now there are so many theorems. We just say the important point is, if you want to solve equation 2, what do you need to do? You just need to find fundamental set, y1, y2. Then linear combination will give you all the solutions. Okay, now let's look at the example for it. Let's use our old example we used in the last class. y0 equal to 2, y prime 0 equal to minus 1. Okay, in the previous class we already learned that y1 e to the t is one solution, and e to the negative t is another solution. Now I can find another solution, say 4 times e to the t. I can find so many. Okay. Like the fourth one is e to the t plus e to the negative t. Okay, in the previous class we already checked e to the t is a solution, e to the negative t is a solution. Now let's check, is this one a solution? What do you need to do? Put it back in the equation. So before to do that, we need to find a derivative. Okay, take derivative of y3. E to the t, you take derivative equal to itself. Take derivative again. Still give you this. So therefore y3 double prime minus y3, which is 4e to the t minus 4e to the t, is still solution. Okay. So you have so many solutions. In order to solve this, I call problem 3. In order to solve problem 3, find all the solutions, we need to find fundamental set. Okay. Now we have 4 solutions here. Let's see they form a fundamental set or not. So now let's check y1, y2. Okay, see y1, y2 form fundamental set or not. Okay, this is Wronskian determinant for y1 and y2. y1 here is e to the t, y2 is e to the negative t. And y1 prime, derivative of that give itself. y2 prime give you e to the negative, a negative e to the negative t. Okay. So we calculate determinant. So you multiply those two. You got e to the t times the negative e to the negative t. Subtract e to the t and e to the negative t. E to the t times e to the negative t give you 1. So you got a minus 1. This one give you another 1. Minus 1 give you minus 2, which is not 0. In the other words, those two form a fundamental set. Okay. Now let's find Wronskian determinant of y1, y3. See they form a fundamental set or not. Okay, y1 is e to the t. y3 is 4 times e to the t. This is a derivative, is self. Derivative of y3 is also equal to itself. So you got 4 e to the t times e to the t, subtract 4 e to the t times e to the t. They give you 0. Okay. In the other words, y1, y3 does not form fundamental set. The difference is, if they form fundamental set, then like say y1, y2, this will give you all the solutions. On the other hand, this one will not. If you put like C2, Y3, they will not, because your C1 like e to the t, right? Your C2 is 4 times e to the t. You put them together, you got like a C1 plus 4C2 e to the t. So no matter how you chose your C1 and C2, they will never give you this solution, right? Okay. So find fundamental set of the solutions is very important. Okay, now let me summarize what we learned. So for the second order linear equations, we know the solution exists in an interval which P, Q, and G continuous, and also this interval contains initial point t0. Okay, if solution exists, how do we find them? So how do we find a solution for this one? What do you need to do? Find two solutions, y1 and y2, such that they form a fundamental set, which means you just find that Wronskian determinant. If not 0, then those are good set. Then if you find a fundamental set of a solution, then the linear combination will give you all the solutions.